equation, we want to use our key strategy. We want to use our key strategy of common denominator by the least common denominator by the least common denominator by the least common denominator to clear the denominators that are in there. And we can see for this problem, x minus 9 is equal to x minus 3 times x minus 3. That's the difference of 2 squares. So that's the difference of 2 squares. So 3 times x minus 3 as x plus 3 times x minus 3. So x minus 3 is a factor of the right-hand side denominator of the right-hand side denominator, and so have a common denominator of x minus 3 x plus 3 times x minus 3. So we can multiply the numerator x. So we can multiply the numerator x 3 times x minus 3 times x minus 3 over x minus 3 over x minus 3, and then on the other side, plus 15, x plus 15, x plus 3 times x plus 3 x minus 3 times x minus 3 divided by x plus 3 divided by x plus 3 times x minus 3 times x minus 3. So on the left-hand side, the x minus 3. On the left-hand side, the x minus 3. On the right-hand side, cancel both. On the right-hand side, 3 and x minus 3 cancel. X plus 3 and x minus 3 cancel. So we get x times x plus 3 times x plus 3 equals x plus 15 equals x plus 15. This is going to turn out to be a quadratic equation because when we multiply it out, we get x squared plus 3x. And so those are not like terms, so I can't combine them. But what I can do, we can solve this by factoring. If I move the x term to the other side, we get x squared plus 2x equals 15. If I subtract 15 from both sides to move that to the other side, I want to get 0 on one side of the equation and all the other terms on the other side. And now the hope is that we can factor this and set each of the factors then equal to 0 to find solutions. And we can, because negative 15 is negative 3 times positive 5, and negative 3 plus positive 5 is equal to 2. So this factors as x minus 3 times x plus 5. So one solution can come from x minus 3 equals 0. The other solution can come from x plus 5 equals 0. So we see x equals 3 as a possible solution and x equals negative 5 as a possible solution. But now with rational equations, we need to be extra careful and make sure that these are actual solutions to the original equation. So if we go back and think about the original equation, it becomes pretty clear right away that 3 is going to be a problem. Because if I plug 3 into that original equation, 3 minus 3 is 0, and that's undefined. So this is not a solution, this is a false solution, or it's sometimes called an extraneous solution. X minus 5, on the other hand, hopefully, x minus 5 is hopefully an actual solution to the original equation. So let's take a moment and kind of think about that. Does that actually solve the original equation? So we can plug that in and check. It's not going to cause a problem with 0 in the denominator, but we want to check our arithmetic and make sure we didn't make a mistake somewhere. So on the left-hand side, we get negative 5 divided by negative 5 minus 3. On the right-hand side, I get negative 5 plus 15 divided by negative 5 squared minus 9. So this will be negative 5 divided by negative 8, which is the same as positive 5 over 8. This is going to be the same as 10 over 25, positive 25 minus 9, which is the same as 10 over 16, which is also equal to 5 over 8. So it turns out negative 5 does work. Positive 3 is a solution to our simpler equation, to this simpler equation, but it's not a solution to the original equation. So we can't count it as a solution to the equation that we're actually trying to solve. So the only solution is x equals negative 5. I hope you enjoyed the video. Thanks for watching.